In this video, our goal is to start solving problems based on the probability methods we have established so far. In this first example, we consider a standard deck of cards that contains 52 cards. I've included a picture here for those of us who are visually inclined. And it consists of four suits. You have what? The clubs, you have the diamonds, so you have the clubs, you have the diamonds, you have the hearts, and you have the spade, and all that fun stuff. So the suits are clubs, diamonds, hearts, and spades. And my interest here is to note that in each of those suits, there are 13 cards consisting of an ace, 2, 3, 4, up to 10, jack, queen, and king of that suit. So our interest here is to compute a couple of probabilities. If we are to compute the probability of randomly selecting a heart or club from a deck of cards, these two events, which is selecting either a heart or a club, is associated with the or here. So the first thing I will think of is, are these mutually exclusive events? So where are the hearts in this case? Well, let me grab a picture here. Let me grab this. So I have what? The hearts here. And then the clubs. That would be the last one there. And you will notice that for the hearts and the clubs, they are mutually exclusive. They have no card in common. There is no heart, there's no card that is both a heart and also what? A club. So these are mutually exclusive events. So probability of a heart or club will be probability of hearts separately plus probability of clubs separately. And that will be 13 out of 52 plus 13 out of 52. That will be 26 over 52, same as 0.5. On the other hand, by extension rather, to compute the probability of randomly selecting a heart or a club or a diamond, of course, you have the diamonds here, you have the clubs, and you have what? The heart. So in this case, you have what? Three mutually exclusive events, probability of heart or club or diamond. Now that will be equal to probability of heart separately, probability of club separately, plus probability of diamond separately. So that will be 13 out of 52 chances for a heart, and 13 out of 52 similarly for clubs, and 13 out of 52 lastly for diamonds, all separate. So this will be 39 out of 52, which is same as 0.75. In those two cases, I wanted to illustrate how to deal with disjoint or mutually exclusive events. Now, I would like to look at a case of not disjoint or non-mutually exclusive events. In this case, we're in part C of the question, where to compute the probability of randomly selecting an ace or heart from a deck of cards. Okay, for an ace, these are the aces here. And then for the heart, I have highlighted that in yellow. Here's a consideration. There's a particular card that is both a heart and also an ace. So these are not mutually exclusive events. It is possible to pick a card that combines both events, being an ace and being an heart, and being a heart. So probability of ace or heart in the case of non-disjoint events, with probability of ace separately plus probability of heart separately minus the probability of ace and heart. And why are we subtracting that? We'll soon see. You see, if I were to count the probability of ace, how many chances do I have of an ace? I have 4 over 52 chance of the card I'm randomly drawing being an ace. And for the probability of a heart, I have 13 over 52. So I'm going to write that down. But you might have noticed something. We have counted this particular guy right here twice. The first time was when we counted what? The aces. It was part of the 4 we counted earlier. But again, when we're counting that of heart again, we counted it twice. That is not good. So we have to subtract one of the 2 times we subtracted it. And how many of it do we have? 1. So we have 1 over 52. And so this makes logical sense. So you have 16 over 52, same as 0.3077. The next part of the question says you to compute the probability of selecting a 2 or a club from the deck of cards. Okay, so if I were to look at that, I'll look at probability of a 2 or probability of a club. Then do I need to subtract something based on double counting? If I look at the 2's, I can see that. And then if I look at what? The clubs, I can also see that there's an intersection somewhere. So this means these are not disjoint events. So I want to look at probability of a 2 and a club. That would be, for 2's, I have 4 over 52 2's. And for the clubs, since it's a suit, I have 13 over 52 of them, minus, there is one card that's been recounted twice. So again, similar to the last example, we have 16 over 32 over 52, which gives 0.3077. With that said, let us consider yet another example. In this example, we've been told that the probability of an event E is 0.40 and the probability of event F is 0.40. We have to find the probability of event E or F if the probability of E and F is equal to 0.05. Since this is not 0, I know that E and F are not disjoint events. So using the general addition rule of probability, which says that the probability of E or F will be the separate probability of E first, plus the separate probability of F next. And since they are not disjoint, probability of E and F will be subtracted for being counted twice. So based on this, I can plug in the values. Probability of E is 0.40. Probability of F is 0.40. Probability of E and F is 0.05. So this should give me 0.75. In the next example, we consider a slight twist to the question. We have been given the probability of E, the probability of E or F. I've also been given the probability of E and F, and I'm to compute the probability of the event F. In this case, the probability of E or F, again, using the similar rule, it is the probability of E plus the probability of F minus the probability of E and F. So we proceed to drop in their respective values. 0.90, probability of E is 0.60, probability of F unknown. I will represent that just for choice and ease of writing as X, minus probability of E and F, that is 0.05. 0.90 is equal to these numbers are what? Similar. So what do we have? In this case, you have 0.60 minus 0. What? 0.05. That will give us 0.55 plus x. Okay. Subtracting 0.55 from both sides, I would have what? This cancels out, and this should give me 0.35 equals what? X. My x is the probability of f that I'm required to find. All right, let's consider one last example on this page. And here we have Marco join John and Clarice and Roberto work for a publishing company. The company wants to send two employees to a statistics conference. And to be fair, the company decides that the two individuals who get to attend will have their names randomly drawn from a hat. Question A. We are to determine the sample space for this experiment. That is, what is the set of possible two individuals who will get to attend this conference? That is, so what we're trying to do here is to list all possible simple random samples of size 2. So we could say that Marco will go with what, John? That's a possibility. So sample space will be Marco going with John. It could be Marco going with Clarice or Marco going with Roberto. Similarly, it could be the case that John will go with Clarice or John will go with Roberto. If you said John go with what, Marco, that is already accounted for here. Marco going with John is John going with Marco, since there is no ordering structure. Okay? And then next you have what? Clarice going with Roberto. These are the possible samples of size 2. Based on this sample space, can we compute the probability that Clarice and Roberto will attend the conference? So probability of Clarice and Roberto, what would that be? That would be the number of points that satisfy that, and that is just 1 out of what? The entire 6 possibilities. So the probability that Clarice and Roberto will attend the conference together, that will be 1 over 6. Next, what is the probability that Clarice attends the conference? Clarice, that means regardless of who she's going with, what is the probability that Clarice would attend? Well, 2 persons are supposed to go, so it is Clarice going with just any other person. And that would be, in this cases, 1, 2, and 3. So the count in that case will be the probability of Clarice attending. Out of 6 possibilities, there are 3 chances, 1, 2, 3, that Clarice will attend with some other person. Okay, with that said, let's consider question D. This says, what is the probability that Roberto stays at home? That is equivalent to the probability that not Roberto. We write that in statistics as probability of Roberto complement or probability of Roberto prime. This is called usually the complement of an event, which we're going to consider in future videos here. All right, so this is just going back to the space and accounting for cases where we don't have Roberto. That will be 1, 2, and 3. Because in these cases, Roberto is staying at home and not going to the conference. And that is 3 over 6.